In this video, we're going to talk about some of the vocabulary needed for solving equations. So our first vocab word is term. Terms can be numbers, variables, again, letters that stand for numbers, or the product of a number and a variable. If a number and a variable are touching, it's indicating multiplication. So negative 1.5t would mean negative 1.5 times whatever t stands for. So an example of a term, we have negative 3x. 4 would be a term by itself. It's actually a constant. Negative 1/3 m. Again, we could also have decimals. Our next word, expression. Expression is a group of math terms containing numbers, variables, and operators. Operators being like addition, subtraction, multiplication, and division. I always used to think the x in expression crossed off anything about the answer. So an expression is like a phrase. It's not a full sentence. Negative 4m plus 2 would be an example of an expression. Again, I know nothing about the answer. If m is not defined or they didn't tell me what m equals, then I'm stuck here. I can go no further with this expression. An equation is a math statement that shows the value of two expressions are equal. So equation, if you look, it almost has the word equal hidden in it, right? The t there. An example of an equation, we have negative 4m plus 2 equals 14. In this case, we could move forward and we could solve for m. So that's one of the things we're going to work on this unit. Coefficient, a quantity or value or amount placed before multiplying the variable in an expression. So in this expression, the coefficient would be negative 4. Negative 4 times m plus 2. The negative 4 is the coefficient. I used to think with coefficient, co means like together. If you're co-teaching with someone, you're teaching together. A co-pilot, you're flying together. And then efficient, meaning it works well. So they work well together. That used to help me remember that the number in front of a variable is the coefficient. A variable, a quantity represented by a letter that may change. So in that same expression, m would be our variable. Constant is a number that's on its own in an expression. So in this case, the negative 2 is constant. No matter what m is, they could tell me that m is 10, and I'd have to multiply it by negative 4. They could tell me m was 92, I'd have to multiply it by negative 4. No matter what my variable is, my 2 stays constant. Whatever this term multiplied out to be, the product we would have to add 2. So it stays constant. Sequence. In math, a collection of numbers or terms that follow a pattern. This would be a sequence. So looking at this set of numbers here, can we notice any kind of pattern? So if we look, we can see that every other number is being subtracted by negative 2. And then we have plus 1 here. So what do we think the next two numbers would be? Well, we would have to add 1 and then subtract 2. So our next two numbers would be 3 and 6. So we're looking for a pattern if we are working with the sequence. A pattern is repeated design or a reoccurring sequence. So again, we have some numbers here. And in this case, our relationship, we have some number being squared to get to our next term. The distributive property lets you multiply a sum by multiplying each addend separately and then adding the products. We've done some work with the distributive property, but we haven't worked with variables within it. So an example of the distributive property, we have negative 3 times x minus 2. In this case, we can't move forward with x minus 2 because we don't know what x is, but we can multiply both terms within the parentheses by the negative 3. So we have negative 3 times the first term and negative 3 times negative 2. If we used additive inverse, we could rewrite this as plus -2. So -3 times the first term and -3 times the second term. And sometimes there could be a third or fourth term. In this case, we only have 2. And then we would simplify from here. We can show -3 times x with them touching. And a negative times a negative is a positive. So we get -3x plus 6. Again, distributive property. The associative property lets you add or multiply. So this only works with addition or multiplication, regardless of how the numbers are grouped. So we have 3 plus 4 plus 2, with the 3 and the 4 grouped together, or we could group the 4 and the 2 together. 3 plus 4 is 7 plus 2. 4 plus 2 is 6 plus 3. Either way, we're going to get 9 as our answer. I used to think with associative property, the SO, remind me, same order. My numbers, the order doesn't change. It's the grouping that changes. I also used to think associative, like who you associate with would be who you group yourself with, to remind myself we were talking about the grouping. And then our last word, we have commutative property. Commutative property lets you, again, we're working adding or multiplying. This does not work with subtraction or division, but the order doesn't matter. And I used to think CO for change order. So we have 3 times 4 times 2, and then we have the product of the same numbers but in a different order. 3 times 4 or 3 times 2 first. And then when we multiply by that last term, either way we would get 24. The order doesn't matter. Again, this is some of the vocab that you'll need for solving equations.